In this video, I'm going to teach you how to do statistical analysis using R. I'm going to show you how to do a t-test, I'm going to show you how to do linear regression, and I'm also going to show you how to interpret the results of those tests. Hang on, hold the phone, there's actually more. I'm also going to show you how to use dplyr. That's a package you can install into R. It lets you do very sophisticated data manipulation. And I'm going to show you how to use ggplot2, and that's for data visualization. So there is a lot to get through. So sit back, enjoy, buckle up, let's do this. Welcome back to this Global Health YouTube channel. If this is your first time here, I'd love to have you subscribe. Now just briefly, what is R? R is a programming language, and we use it to do statistical and quantitative analysis. Now I know what you're thinking. You're hearing the words programming language and that sounds extremely scary and intimidating. It's not. It's actually very easy. It's simple to use. Follow the step-by-step guide that I'm going to give you and I promise you, you won't go wrong. I'm actually going to be doing this analysis using a data set that you can download and install onto your computer so you can practice along and do exactly what I do at home on your computer. So why is the whole world moving to R? The big thing is it's free. Completely free, absolutely free. Are there any hidden costs? Absolutely not. It's free, you can download it and use it today. Before I carry on, just a quick thank you to the University of Edinburgh for sponsoring this video. I couldn't do it without your support. The University of Edinburgh offer a number of fantastic online distance learning master's programs, including a master's in public health and courses in data science, technology and innovation. I've had a look at their curriculum and believe me, it's a fantastic place to learn. Highly, highly, highly recommended. So if you want to find out more, just click on the link in the description below. Right, let's get stuck in. So this is RStudio. At the top on the left is where we're going to write our code. Beneath that is the console where you're going to see the outputs. In the top on the right is the environment where we'll see any objects that we create. It's over here. And plots that we draw are going to pop up at the bottom on the right over here. To install the Gapminder data that we're going to be looking at, type the command install packages and then Gapminder and put it in inverted commas. And that's going to download the data onto your computer. You only ever have to install these packages once, but whenever you want to use them, you've got to call them. And to do that, you use the command library. So type library, Gapminder, no inverted commas this time. Now you can, but you don't have to type the command data and put in Gapminder. And this is going to make it visible as an object in the environment on the right. If we click on that object, we can see the data set pop up on the screen. So we've got country, continent, year, life expectancy, population, and GDP per capita. Now the way R works is pretty straightforward. What you do is you apply functions to objects. So we can apply the function summary to the object Gapminder, and R will provide us with a summary of each of the variables in the data frame. In this case, we've got the minimum, the maximum, the median, the mean, and the interquartile range. And of course, we can apply functions to subsets of our data or just to one variable, for example. So we can, for example, type in the name of the data set and then a $ followed by the variable that we're interested in. In this case, we'll have a look at the mean of the GDP per capita. And we can see the output down over here. Whoa! And here's a nice little trick. We can create new objects by assigning them with this little arrow sign. In this case, we're going to assign this line of code to the character X. And now we can see a new object in our environment. And if we call X, we can see that it produces the mean of GDP per capita as expected. Now, if you're a little bit lazy like I am, and you don't want to be typing in the name of the data frame every time you want to refer to a variable, you can simply use the attach function. So type the command attach, then the data frame. After that, you can just simply refer to the variable without having to use the name of the data frame and the $. So for example, we might want the median of the population, and there is the median value for the population. We can also use some graphics functions like the histogram for life expectancy, or for population. Now that looks a little right skewed. Oh, no. So we might want to do a log transformation of that data, and voila. Now I'm not going to get into why we do log transformations in this video. I'll do another video sometime and talk about that. We could also do a box plot and look at the distribution of our life expectancy data disaggregated by continent. Let's zoom in on that. And to look at the relationship between two numeric variables, we might want to do a scatter plot. So for example, life expectancy as a dependent variable on the y-axis and GDP per capita as the independent variable on the x-axis. Now that graph isn't particularly linear, so we might want to do a quick log transformation on that. And voila. Now we're going to be doing some much more sophisticated data visualization using ggplot2 in just a few minutes, so stay tuned. Right, now we've got a data set and we might want to start by doing some data set manipulation. And to do that, we use a package called dplyr. So let's imagine we've got this data set. We've got eye color, we've got height, weight, and age. And we might want to know what is the average BMI, body mass index, for people that have blue eyes. Now, once we've installed the dplyr package, and we do that exactly the way we did an install package earlier, we've got access to a whole lot of new and interesting vocabulary we can use in R, and we've also got access to something called the pipe operator. And let me show you how that works. We start off by typing in the name of the dataset that we're looking at, and then we put in this pipe operator, and it looks a little bit like a pipe because it's a percentage greater than percentage. And what the pipe operator does is it takes what's ever to the left of the pipe operator and pipes it into the next line of code. Let me show you what I mean. Just watch. So firstly, we might not want to use all of the variables in our data set. We want to select the variables of interest. In this particular case, it's eye color and weight and height. Now think of the pipe operator as using the term and then. So we've done select, and then we want to filter out rows that match some criteria. In this case, people that have blue eyes. And then let's use mutate to create a new variable called BMI, which is equal to weight over height squared. And then let's create a summary, and we'll create a summary variable called average BMI, which is of course equal to the mean BMI. So let's practice our new data manipulation skills using the dplyr vocabulary and the pipe operator on our Gapminder dataset. I've already installed the package dplyr and called it into the session using the library command. So let's start by typing in Gapminder, and then let's select the variables country and life expectancy. Now we can see just the country and life expectancy. So we've used select to narrow down the columns that we're working with. So now we want to focus on just a subset of the rows. So we want to filter out particular countries, for example. To do that, we type and then, which is the pipe operator, filter by rows that meet a certain criteria. In this case, we want countries that are either South Africa or, and the vertical line is the equivalent of saying or, Ireland. And then we want to aggregate our data by the two countries. So we say group by country, and we can now create a summary value for the average life expectancy in each country by typing average life equals mean of life expectancy. And here we can see that the average life expectancy in this data set for Ireland is 73 years and for South Africa is 53 years. So we can see there's a difference between the two countries in terms of life expectancy of about 20 years. We want to know, is that difference statistically significant? Before we do that, I'm going to teach you a little bit about statistics, just in case you're not familiar with some of the concepts. Right, let's imagine that we work in a factory. This factory produces jars of fizzy drinks. We've got 100,000 fizzy drink jars. These jars are filled with either purple fizzy drink or green fizzy drink. Now, the extent to which these jars are filled is variable. There's a lot of variation. And we want to know, is there a statistically significant difference between the two groups in terms of the average extent to which they're filled with their respective colored drink? So firstly, we've got a sample of our jars. We don't have all 100,000 jars with us. We're going to take a sample of jars and have a look at those and make inference. We're going to infer something about the larger population of jars. And we can see that in our sample, there is in fact a difference in terms of the average extent to which the jars are filled with their respective colored drink. Now, because this is a sample, of course it is possible, even if we randomly selected jars, that we happen to, by chance, select jars that demonstrated this difference. So the difference could be due to chance, or it could be real. Well, we start off by assuming that we're wrong. We start off by assuming that in the population, in the 100,000 jars, there is in fact no difference in terms of the average extent to which the jars are filled. That's our null hypothesis. And if the null hypothesis is in fact correct, then our sample difference was just due to chance. Well, how can we possibly know? Well, we apply something called the t-test, and that's going to check this assumption. And the t-test produces a p-value. The p-value is the probability that that null hypothesis is in fact correct, that there is no difference. And if that probability is very, very, very small, then we can say we can reject that null hypothesis. We don't believe it, and we can believe the alternative, that in fact there is a real difference between the average extent to which these bottles are filled. And of course, the t-test also gives us a 95% confidence interval, and that's the range within which we can expect the true difference in the means, in the average extent to which these bottles are filled, can be found. So let's do this exact same exercise, but on our Gapminder data. Right, so we've observed a difference in the average life expectancy between South Africa and Ireland. Is this due to chance? Let's do a t-test. To do this, we're going to create a new data frame, and that's going to be filtered for South African and Irish data, and we're going to call that data frame 1 or DF1. And to do this, I'm going to delete the extra code, and we're left with code that takes Gapminder and then selects our two variables of interest, which is country and life expectancy, and then filters by the two countries of interest, which is South Africa and Ireland. And now data frame 1 or DF1 is in our environment. We can click on it and take a look. Now apply the t-test to data equals DF1 and compare the average life expectancy in the two countries. What does this tell us? We can see that the average life expectancy in South Africa and in Ireland is 53 years and 73 years respectively. So our observed difference is 20 years. And our question is this: if there isn't actually a difference in the life expectancy between these two countries, if the difference between the average life expectancy is in fact zero, so that's our null hypothesis, then what are the chances that from our sample we would get the difference that we observed? Well, the chances of that happening, the probability of that happening, is the p-value, in this case 4.4 times 10 to the power of -9. That is very, very, very close to zero. And because it is so unbelievably unlikely, we can reject that null hypothesis, the assumption that in actual fact the difference between the means is zero, and we can accept the only alternative, which is that the difference between the means is not zero, that there is a real difference. And we have our 95% confidence interval for where we think the real difference is. It's likely to be between 15 and 22 years. Now I want to show you how to produce some fantastic graphics and data visualization using the package ggplot2. And just a quick note, throughout your career, you're going to need to use and communicate data. And that's why I think using a free package like R is so important, because it means wherever you're working, whatever job you have, you always have access to a package that you know and understand. So I was really excited to learn that the University of Edinburgh actually provide a course in quantitative analysis using R. And I think that that is actually a huge selling point for their MPH program. Okay, back to R and let's talk about ggplot. Again, we install the package ggplot2 and tell R that you want to use it in this session using the library function. And again, we're going to start by using the dplyr pipe operator to pipe data into ggplot. So we start by saying what data frame we're using, in this case Gapminder, and then filter by GDP per capita less than 50,000. And I'm just doing this to show you how easy it is to use the pipe operator to have a lot of control over what data gets fed into your graphics. And then pipe it to ggplot. Now, I don't have time in this video to teach you everything there is to know about how to use ggplot, but what I do want to do is give you a quick demonstration so that you get excited about ggplot and the data visualization, and you can do the exact same data visualization that I'm going to be doing at home using Gapminder on your computer to practice. First, we tell it what aesthetic to use, in other words, how the variables are going to be represented on our canvas. And in this case, we want GDP per capita to map out against the x-axis and life expectancy to map out against the y-axis. And we want to add to that, using the plus sign, what geometry needs to be applied to the canvas. And in this case, we want just a point or a dot to be drawn, so we use the geom point. So when we run that, we land up with a graph that's very similar to the one that we had earlier. And so why is it that I'm so excited about ggplot? Because this seems a little bit more complicated. Well, the truth is, and stay with me now, we're going to make some small changes and turn this into a very rich data visualization. Let's make the continents into different colors. And now you can see all the continents are represented by different colors. It looks a little busy, so let's make the points a little transparent by using alpha equals 0.5. That's a little better. Let's make it 0.3. And we can make the size of the dots proportional to the size of the population. So here we can see that the bigger dots are representing the more populous countries. And of course, we can do the good old log transformation to the GDP per capita data. And you can see that the data is looking a lot more linear now. And let's add another layer to our canvas. Let's put in a line that tracks the various continents using Geom Smooth. Now it's a little easier to see the differences between the continents. We can make that into a linear model by saying method equals LM. Let's zoom in. It still looks a little messy. Let's divide out the various continents into separate facets using facet wrap. And let's zoom in on that. Given that our continents are in different facets now, we don't need to use color to distinguish between them. We can use color to represent the different years, and voila. Now we have one graphic that includes life expectancy, GDP per capita, population size, continent, and date. 5 variables in one graphic that doesn't look too busy or too messy. You've got to love that. Now again, I don't have the time in this video to go into a lot of detail about simple and multivariate linear regression, but given that we're working with the Gapminder data, let me show you how easy it is to just do a quick linear regression model and look at some results and try and explain them to you. So very briefly, a linear model tries to represent your data using a best fit straight line. That line is going to have a slope and will have an intercept with the y-axis at some point. So we type LM, that stands for linear model. And we start with what we think is the response variable, in this case life expectancy, and then the explanatory variable, in this case GDP per capita, which we think might explain some of the changes in life expectancy, and this gives us an intercept and a slope. Now if we ask for a summary of that model, we type in the word summary in front of the model, we get the residuals and the coefficients and a couple of other bits and pieces of information that I'm not going to get into in this video. In this case, the p-value is the probability that the slope is in fact 0. That's the null hypothesis, and it's very, very small. So the slope is not 0, or it's unlikely to be 0, so this coefficient is statistically significant. And very quickly, just to show you how easy it is, we can do multivariate analysis simply by adding additional explanatory variables to our formula. In this case, we'll add population. And voila, we have significant p-values for both explanatory variables. And these, of course, because it's regression modeling, these control for each other. And this, of course, would be even better if we did log transformations of those data sets, because we know they're very right skewed. But for the sake of time, I'm not going to do that right now. Don't go anywhere. Stay and watch another video. I've got other videos on research methods and data analysis if you're interested, so check them out. Subscribe to this channel if you haven't already. Leave your thoughts, suggestions and questions in the comment section below. And once again, a big thank you to the University of Edinburgh for their support. Until next time, take care.